Good morning, good morning, good morning. All right, today we are going to start a new unit. We're going to go over parts of a circle, and this is going to be a little vocab heavy. So as you can see, I kind of filled in some of these blanks already, so you want to make sure to go ahead and get those written down. But also make sure that you understand the vocab. Some of them are going to be pretty simple because you've probably seen them in the past. Some maybe not so much. All right, so first term that we need to know, what is a circle? So a circle, okay, is a three-dimensional shape made by drawing a curve that is always the same distance from the center. Okay, so what does that mean? Well, if I draw a circle, okay, that's exactly what it is, and then I could put a dot directly in the center, and this distance has to be congruent to this distance, right? Where is the center of the circle? Well, the center of the circle is all the points on the circle are the same distance from the center of the circle. So we could really copy and paste this, but say that we could also continue to draw lines, right? So this, it doesn't matter where at on the outside of the circle, but it's going to be the same distance every single time. So if I can get it to draw a straight line, there we go. Okay, this is all the same. So it's kind of like, if you were to think about pi or something along those lines. So that's the center of the circle. It's when it's the same distance to the outside no matter where it's at. What is the radius of a circle? The radius is the distance from a center to the point on the circle. So the radius, if I draw a circle, and then I put a point, and I draw this line, and let's say I call this point P and point Q. So we would say PQ is the radius. Okay, it's from the center to the outside. A chord. Okay, this one might be kind of new. A chord is a line that has two endpoints on a circle. So what do we mean by that? Well, if I draw again another circle, okay, and I'm actually going to shrink this one down. All right, so a chord connects 2 points, but the key thing here is a chord stops at the edges. Okay, so if we called this AB, we would say AB is a chord, but the endpoints are on the edges of the circle, and that's important because the difference is the secant line of a circle. A secant line looks very, very similar, but a secant line goes all the way through. Okay, so a chord does not, whereas a secant does, right? So that's the difference between the two, and they get confused a lot, so make sure to pay attention to that definition. Diameter. A diameter is a line that passes through the center of the circle. So again, if I change colors here and I draw a circle, okay, if this is the center, then a diameter goes all the way across. So if this is, I don't know, YZ, we would say that YZ is the diameter. And remember that the diameter is 2 times the radius. Okay. All right, so tangent line of a circle is a line that touches a curve at one point without cutting across it. So again, draw a circle. Okay, so let's say that there is a point there. So a tangent line cuts across that point, just like that, right? So it just touches the circle at one spot. And typically it'll be like A, B, and so you'd say line, segment, AB, which continues on, is a tangent line. Point of tangency, the point at which the tangent line touches the circle. So this one's really simple, right? We have a tangent line. Okay, we have A. We connect it. So you would say B, point B, is the point of tangency. Okay. Last one, a common tangent. A common tangent is a line that is tangent to more than one circle. So if I have a circle here, and I have a circle here, okay, This is called a common tangent because it touches both circles at exactly one point, right? So that would be like circle A and circle B have a common tangent, and usually you'll label that as well. So like, let's say this is FG. So you'd say line FG is a common tangent. Okay. All right, use the diagram to the right to answer the following questions. BC, so line BC is a blank because C is the center and B is a point on the circle. So CB is right here. It's about half the distance. We know half the distance of the circle is called the radius. EA is a blank because it is a line that intersects the circle at 2 points. So EA, but notice how it continues on through. So that's going to be a secant line. DE, oops, let's see, DE runs outside right here, okay, but notice it touches the circle at exactly one spot there on the edge, so we call that a tangent line. Okay, AB is best described as a blank of the circle. So AB goes all the way across. Okay, you could label it as a chord, but in this case, we're going to say it's a diameter because it does run the length of it. All right, so use the diagram to the right to find the answer, to find the given length. So number 1, radius of circle A. So circle A, this has got to be in the center because this has to be equal distance, which it is, so that's 2 and 2. So it says radius, well, radius to the side is 2 units. Okay, diameter then would be double that, which is 4 units. Radius of circle B. Circle B goes from here all the way outside. So it'd be 1, 2, 3, 4. 4 units. And the diameter then is double that, which is 8 units. And you could always verify that by saying 4 plus 4, right? All right, next part says tell how many common tangents the circles have and draw them. Okay, so there are probably going to be a few here, but we have at least one, and it looks like at least two common tangents. Okay, and I would even argue 3 common tangents. Okay, this one, notice the circles overlap, so you can't draw that one in between, but you can draw one over here, so that gives it 2 common tangents. And this one, the only place where you can touch a line and it only touches both of them one time is right there, so this is 1 common tangent. Okay, theorem number 1 says in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at the point of tangency. Let me plug in my iPad here. It's dying out. So. Okay, so a line is tangent. So like they're saying this line is tangent if and only if this line is 90 degrees from it, right? So that's what it means to be perpendicular. So example on the next one says, in the diagram to the right, point B is a point of tangency. Find the radius of R of circle C. So what they said is point B is a line of point of tangency, which tells you that that's a right angle, right? So now I'm looking at this and I'm saying, oh, so now I have a right triangle. And I have 1 side length, 2 side lengths, 3 side lengths. So I don't need to use trig here, but rather, since I'm given the side lengths and I want to know what R is, I'm going to set it up with a squared plus b squared equals c squared Pythag. So I have r squared plus 77 squared equals, and the hypotenuse is always across from the right angle, and it's always on the side by itself. So this is a distance of r plus 49, right? Okay, so we have r squared. Let's see. Grab my calculator here. 77 squared, 5929, And when you're squaring a binomial like this, we have to set it apart and say this is r plus 49 times r plus 49, right? So this is where we FOIL, if you remember back to freshman year, and potentially some from last year, so 59, 29. Okay, first, r times r is r squared, r times 49 is 49r, 49 times r is 49r, and 49 times 49 is 2,401. Okay, so we don't have r by itself yet, but remember we can combine like terms. So I have r squared plus 49 is 98r. Okay, and then on this side I still have r squared plus 5929. Now notice I have this r squared here and I have an r squared here, so I'm going to subtract it from both sides. Okay, like if I'm taking this one over to the left, I got to subtract both sides of the equal sign, right? And that actually cancels them. So I have 5,929 equals 98r plus 2401. Then I can just subtract the 2401. So 5929 minus 2401 is 3528. Okay, then divide by 98. So R is 36. There you go. So a little bit of work here to find that, but honestly it's not that difficult of work. It's just remembering that you can combine like terms or add and subtract, or how to FOIL, right? So r equals 36, there's our answer. We're done with that because that's what I wanted to know, was find the radius. We just did that. Okay, theorem number 2 says tangent segments from a common external point are congruent. So as you notice, okay, this is the tangent line because it touches the circle right there one time. Same with this one. And since they are both tangent lines and they both come from the same point of S, that means they are congruent, okay? And anytime two things are congruent, you can set them equal to each other. So, for example, it says QR is a tangent, okay? So this is a tangent. I don't know why it does that now. Okay, QR is a tangent to circle C, and QS is a tangent. So that tells us that this one is congruent to this one, and it wants us to know what is the value of X. So we are literally just going to set it equal to each other and solve, because they're 2 points of tangency from the same outside point of tangency, congruent, set them equal and solve. So subtract 5 from both sides. Divide by 3. X equals 9. Done. Okay, so I want you to try these two practice problems. So they're very similar, obviously, to the examples I just did. The answers are here at the bottom, so make sure you get the correct answers. Then once you're done with that, you're going to go on to tonight's exit ticket. So there are these two questions here. One's kind of vocab, so you will do those, submit into Canvas as today's lesson. Have a great day, guys.